So here we are looking at our analysis that's now completed. You can see you get a little heads up here saying it's completed. If you just confirm that, you can look at some of the computation steps that it ran through, but generally we just close that window down and then we can look through our results that we've got from the analysis. Now again, if you're not particularly expert at what these results are going to mean, one of the first things that you can do is select this Results Advisor button. And what this does is it tries to pull out any problems or any potential problems from all these results that you get when you run this analysis. So it highlights certain things. It's highlighted that there are some air traps in this model, so if I double click on air traps, you can see that plot gets selected up here. And what we're looking at is the model now with these small little circular icons on it, and they essentially represent where air is going to get trapped when the thing gets injection molded. So the sorts of things that you're looking at when you're assessing are those air traps a problem or not, are they in areas that require a particular visual quality, because obviously if you have an air bubble trap there, the surface might not be as smooth as the surrounding surfaces. Also, if you get a big collection of these air bubbles, obviously that portion of the part is going to be weaker than the rest of the part, because there's areas there that don't have as much material in them per volume. But yeah, the Results Advisor offers some insight into what air traps are, or what each one of these issues is, and then possible suggestions as to how you might minimize the problem. So we've got suggestions including increasing the filling time, changing the gate location, which we said earlier can affect a lot of these results quite significantly. So that might be something to run another analysis with some change in the gate locations and see if that affects this problem positively or negatively. There's also things to do with the analysis setup to do with injection speed, and then there's something about vents as well, that you can put specific areas in your molding where the plastic arrives at last in the injection process, and then those areas are sacrificial, so they get machined or snapped away before the final product is sent to market. So there's things to be done there as well. One of the other problems, apart from air traps, that it's highlighting here is an unbalanced floor. So generally, whatever quantity of gates you have, it tends to be a good idea to try and get each of your gates to contribute a roughly equal amount of material into the finished part. And you can see that when we look at the gate contribution plot, we get a readout at the top left there, and then we get a visual representation of where the plastic is coming from in terms of the gate that it's arriving through. So you can see gate number 3 is around 25%, gate number 2 38%, so we've already got a mismatch there, and then gate number 1 is contributing 36% of the volume. So 1 and 2 are reasonably well balanced, but 3 not so much. So again, it offers certain suggestions that you might want to try and rerun the analysis again and compare the results to this one. So changing the gate location again, changing the gate diameter. Obviously, if you increase the diameter of the gate, which is currently contributing the least, that should increase the amount of material that can flow through that gate. So that might be something to try and rerun the analysis again. And then it's offering suggestions based on changing the actual part design itself. We'll just have a quick look at the last one. So weld lines. Weld lines tend to occur, or do occur, when two floor fronts meet each other. So you can see from the graphic here, if we had a single injection point on this particular part, the material would come in, it would split into two flow fronts, and then those flow fronts would meet each other on the far side of the part there. And as they meet each other, you get what's known as a weld line. So again, it's describing the problem here. Sharp welding angles found in some places, weld lines may become visible. In general, weld lines will weaken the material in that area. So if the part has any great requirement for strength where a weld line is, then it might be worth playing around with the gate locations again, trying to move the weld lines away from higher stressed areas in the part. And again, you might get a visual indication that there's a weld line there as well. So if there's a great requirement for visual quality on the part, you want a nice even surface in certain parts of the design, then trying to move the weld lines away from that area might be a good thing. So yeah, that's the results advisor. It tries to pull out things which it sees may be an issue in your results. So that would be your first port of call, probably, either as a new user to mold analysis, or even as a more experienced user. We can, however, look at these results individually, so we can go through all these different plots. So if I click on the Moldability plot, you can see that the system's fairly confident that it can fill this entire mold. So it hasn't indicated that any areas have low moldability, so its confidence of fill is relatively high, or is very high for this part. It should be able to injection mold this part, or this part should be possible to injection mold with the setup. There's no areas that are causing a massive amount of concern in terms of filling with material. If we look at the melt front time now, so this is to do with the amount of time to actually fill the part, and one of the nice things that you can do in this plot, rather than just seeing it as a static plot, if you click on view control here, so there's various sectioning tools that you can play around with, but the one that we're going to have a look at is animation. So if we just click on animation here, you get a visual representation of how the mold fills. So again, if you're looking to identify specific problems here, this might give you a greater understanding of the time steps as the flow of material is coming into the mold, how the material fronts are meeting each other. So you can see here that this material front here and these two material fronts meet each other along these lines, and that is one of the reasons that we get weld lines showing up there. So yeah, it gives you a greater understanding of how the mold actually fills. So that's quite a nice tool that you can use as well. So let's have a look at some of the other results here. Maximum cooling time is one that again can be quite useful when you're diagnosing problems in your molds. Again, this is just a static rainbow plot at the moment, but if we click on view control, we can scale the range that we're focusing in on so that we isolate a certain limit in cooling time. So yeah, going through some of the other plots that we can interrogate. We've already looked at weld lines and air traps, but it's worth noting that you can activate them manually in here again. So you can see the number of air traps there. And again, when you're playing around with your setup, running a second analysis, it can be useful to note how many air traps you've got now, change some of the setup criteria, either the number of grit gates or the setup of the analysis itself, the temperatures and the some of the other setup criteria, and then rerun it. And then you want to compare, have I made the air trap problem worse or have I made it better? And the same goes for the weld lines as well. So another important one, volumetric shrinkage. So you may have a data sheet for the particular material that you're using that quotes a shrinkage factor, let's say 1% shrinkage. Now that's an average, that's a bulk number, that 1%. But what we're looking at here is obviously, given this part's specific geometry, some areas of it will be more prone to shrinkage than other areas. And if we look at this part here, hopefully you can see that this wall here is ever so slightly lighter coloured blue than the surrounding walls here. So if we look at the scale here, we can see that the deepest blues here are around 1/3% shrinkage by volume, and then as we progress up into the lighter blues, we're up above 2% there. So you want to create your mold tool to reflect the average shrinkage of this thing, and maybe you want to do a redesign. If one area of this part was seeing markedly more shrinkage by volume than the bulk of the rest of the part, maybe it might be time to consider a redesign of the part to try and get the shrinkage over the majority of the part as uniform as possible. So yeah, volumetric shrinkage. And then the last one that we might want to look at is the gate contribution again. Again, you can go into these individually, you don't just have to go in through the results advisor. But generally, you'll assess these results, maybe you'll keep a record of them, maybe you'll screenshot these results and take a little snapshot to represent what you're looking at. And then you'll decide, well, I'm going to change something about the setup of this analysis and see if it increases the quality of this moulding, see if it reduces things like weld lines and air traps and things like that. And then reassess and see if I've made things better or worse. So the way that you might do that, let's say we made a decision to go from 3 gates here to 2 gates and relocate their positions. So maybe what we would do is go back into the the first thing that we might want to do is go mold analysis files. Let's save this project. So what the system is doing now is it's saving a copy of these results files that we were just viewing, and it's saving them in the working directory where the model file is being saved to. So that's the first thing. Then what we might do is go back into get our gates set up. So if we just go into the gates option this time, you can see the 3 gates that we had in that analysis that we were just looking at are there. So I'm going to select all 3 gates and delete them. Then I'm going to close that window, and again I'm going to use the automatic gate creation wizard again. So automatic gate creation, the pull direction of the mold remains the same, we've not changed that. The coordinate system will remain the same. Let's say I'm now going to put 2 gates in there, and let's say I've made a decision to increase the diameter of the gates as well. Then we go to calculate, and the system goes away and tries to assess what would be the best location for these gates, these 2 gates that we're going to create. So here we are, it's run that analysis, it's suggesting the most sensible places to put these 2 gates. So you can see we've got one down at the bottom there and one up on this vertical face. Again, if we just OK that, it will place those gates where it's indicated. So we'll click on OK. We'll just have a quick check. Yes, there's 1 gate there, and there's 1 gate down underneath the part as well. So then what we'd have to do, if we didn't want to change the material, if we were just comparing like for like materials, and let's say we don't want to change any of the operating process conditions, we're just changing one item here and seeing how that affects the outcome. Then what we do, you can see our 3 gate setup is still stored there. So we'd go, I want to add another analysis into this analysis setup. So again, we'll leave it on course, we'll request that it calculates the sink marks, maximum cooling time as well, so that we're comparing like for like, but the only thing that we've changed is the quantity of the gates, the diameter of each gate, and obviously their locations as well, now that we've gone to a 2 gate setup. So we go add, It gives us that warning again about how when you've done this analysis you can come back out again and relocate the gates. So we'll click on OK there. We get a second analysis. So again, if I double click on the name of this, I can give it a more sensible name, which is 2-gate setup. So this allows you to keep track of these analyses a lot easier. And then again, we've already run the 3-gate, so we don't have to rerun that. What we want to run is the 2-gate, so I'll put a little tick in that tick box. And then we'll just run the analysis. So I'll select run now. Do you want to save the current project? In actual fact, we've just saved it, but let's say yes. Takes a quick save of the whole setup. And then again, we'll pause now and then we'll come back in and see how the new results compare with the older results. So here we are now that the analysis has finished running, and what we're viewing here is the 2-gate analysis. So you can see when we look at the melt front time, you can see that there's obviously 2 entry points into this plot. And then obviously we can run the animation of the melt front time again, just to confirm that. You can see the 2 entry points there where the material is spreading out from. So what we can do at this point is we can look at some of the plots that were flagged as a possible issue last time. So let's have a look at the air trap plot. So just from initial impressions there, the quantity of air traps looks to have gone down quite significantly. I mean, if we wanted to take a quick screenshot of that, which we could do, obviously you've always got the Windows snip tool that you can use here. So this is just a quick way of logging what that analysis looks like. So we'll put that off to one side. And then if we go into the analysis button again, you can see that this analysis, you can see that both analyses have been completed. We completed the 3-gate setup first, and then we completed this 2-gate setup. Currently the 2-gate setup is what's active, but if we want to activate the 3-gate setup now, we can click on it there and click on activate and then close. And now when we look at the air traps, we're looking at the 3-gate setup air traps. So that's just a quick way of flicking backwards and forwards between multiple analyses. So if we quickly bring the screenshot that we clipped back into view, I think we can see that the quantity of air traps in the 2-gate setup is significantly better. So there's less air trapped in that setup than in the 3-gate setup. And what you can do is do this sort of technique with anything that you're interested in. So if we look at the Moldability tab, for example, so we're back in the 3-gate setup here. The entire thing is considered easily moldable. So the system has a high confidence that it can fill this mold. It has a high confidence of fill. And then again, if we go into analyses, click on the 2-gate setup and click activate, and then close that window down. Click on Moldability again, we can see that the 2-gate setup is entirely moldable as well. So that's a good thing. Again, if we want to look at some of these other values, volumetric shrinkage doesn't appear to have changed that much in the 2-gate versus the 3-gate setup. Obviously gate contribution will have changed significantly because we've gone from a 3-gate setup to a 2-gate. Now this is considerably imbalanced. You can see that gate number 1 is contributing far more of the filling volume of material than gate number 2. Now that's not recommended at all. So if we go into the results advisor, you can see it's highlighting that. It's saying unbalanced flow. The flow from the 2 gates is not balanced in terms of the quantity that's coming from those 2 gates. It gives you a little bit of a description of that. The melt contribution for each gate is unbalanced. More plastic melt has been injected through one or more of the gates than the others. How might you change that? Change the gate location. That could be an option. Modify the gate diameter. Again, we've already talked about this. If we want to encourage the material to enter the mold a lot more quickly from one gate, we could increase the diameter of that particular gate. And then again, you can play around with the wall thicknesses within the model to actually encourage the material to flow through the mold more quickly in thicker areas than in thinner areas. That tends to be how you encourage the material to flow more easily. You thicken an area up. Weld lines. The weld lines have changed their location, and again, this will play into what your intention is for the design. If these little pockets here, so this pocket in the design and this pocket in the design, have to hold quite a high mass, so they have to be quite strong, whereas this area in the design, let's say, is under a lot less stress, it would not be wise to create a weld line in this area. So that obviously it has to be taken into account when you think about how your design is performing. What task it's been designed to perform, and are there any areas where a weakness like a weld line would be a larger problem, and if so, if the weld lines are unavoidable, maybe push them into an area that doesn't need such strength, or that its visual quality isn't such a problem. So let's say we want to rerun the analysis and modify the gate locations again. Then what we would do is go into the gates option. Maybe we want to change the diameter of gate number 1, or maybe gate number 2 in this case. So gate number 2 was contributing a much lesser amount of material into the injection process than the gate around this side. So if we increase the diameter of this gate, maybe that will help us cure it. Or conversely, we could reduce the diameter slightly of this gate. Let's do it that way. So let's reduce this one down to 3mm, and then close that down, and then go back into analyses, and we can add another analysis. So now we've got a third analysis, and maybe we will call this 2-gate uneven, because the gates are not the same diameter anymore. And obviously we could run that analysis then, and gradually we can build up lots of analyses, and we can see how changing the analysis setup conditions allows us to correct or to address some of these problems that we can see illustrated in the results files. So yeah, that tends to be how you set these analyses up. So I'm not going to run that 2-gate uneven at this point, because we've done the steps that were involved to actually do that, so we don't need to see that again. Then what you can do is, when you've finished your project, and at this point you don't want to run any more analyses, maybe you'll come back in at a later date and set up some more, but let's say you want to go back into the design of this thing and change the design slightly. What you want to do is go Mold Analysis Files, Save Project, and then you will need a reasonable amount of disk space to save these files into. And then when you quit out of the mold analysis tool, so let's imagine we are going back into the model and we want to change some things, and then when we've made those changes, we want to go back into the molding analysis tool and rerun or re-look at some of the results that we've already created. We would go Applications, Mold Analysis again, and then we would go Mold Analysis File, Retrieve Project, and there's our molding analysis file. So these files have an XEDZ extension on the end of the file, so you can see that there. XEDZ files are the analysis results files. So if you've saved your analysis as saved project there, it will write one of those files into the same folder that your part file is from, and then in order to load those results back in, you have to go to retrieve project, and then it will load the results back in. So again, it'll take it a second to read those off the disk, and then what you can do is have a look at the analyses that you've run in there. And again, if we want to look at one in particular, you select it from the list, click on activate and close, and then all the results should be available. So that's how you retrieve your results files after you've maybe quit out of Creo or gone back into modeling mode. Now, one last piece of useful information: if you go into the Creo help file, so the help file is up here, then you should be able to drill down into the mold analysis part of the help file. So you can see the entire help file here helps you about various parts of Creo, various tools that you can use within Creo, fundamentals, data management. There's all sorts of things in there. One option is mold design and casting. So if you go into there, within there there's a subsection which is Creo mold analysis. So maybe you will want to search for that in this search bar at the top. So inside Creo mold analysis, again, there's lots of different subsections. One interesting subsection that might be quite useful is the subsection to do with analyzing results. And then within there there's an article called About Mold Analysis Results. And what that gives you is a little bit more information about how to interpret the results and the various plots that you look at when you've run an analysis. So you can see there's things about air traps, there's things about weld lines in there, sink marks. All those results that you're seeing, there's a little bit more of a description of them in this help file. So that might be quite useful. And then when you've generated these results, sometimes you want to keep a record of them. So you want to take them onwards into a Word file or create a report of what results you've generated. Well, there's a tool for that as well. So if you click on Generate Report here, and then again, it's good practice to name these reports. So this one was a 2-gate setup. And then maybe put your name on there. If you're working for a company, maybe put the name of the company in there, and any other data that's relevant as well. The two types of report that you can create are a HTML file or a PowerPoint file. So I might intend to clip some of the pictures out of this report and put them in a Word document. So a Microsoft PowerPoint file would probably be more useful to me. So I'm going to select PowerPoint, and I'm going to select Analysis Results Description. You're going to have to specify a path to save this report file into. So I'm going to just drop it into the same folder that I'm working in with my part files, but you don't have to. You can save it any way you want to save it to. Click on OK, and what the system does is it runs through all these plots, and it takes a record of them, and then in the background it generates a full PowerPoint presentation which presents all this information so that you have a copy of it then, even when you're not inside of Creo. You can show these results to someone else, pass them on to colleagues, and as I say, you should be able to copy and paste the pictures out of these, or the diagrams out of these reports, and put them in your own either Word report or whatever document you're compiling. So I think that's complete now, so we should be able to, there you go, there's the confirmation, confirm. Then what we're going to do is browse to that and see what's included in that report. So here we have our PowerPoint report of the 2-gate setup that we've just generated. You can see that we're in PowerPoint now, and if we quickly just have a look through some of the slides that are in here, so if we quickly go down through them, you can see it lays it out in quite a logical sort of professional looking manner. And then if you browse down through these, you can see it's telling us something about the setup of our analysis, polymer type, manufacturer, summary of our setup conditions, so our process conditions, what temperatures we ran this at. Then we get into some of the plots, and one of the things that this might be useful to you, one of the reasons it might be useful to you, is it gives you descriptions of problems and things to look for and possible issues that you might want to address in the text that accompanies each plot here. So you can see we've got various plots that it's pulled out of the Creo results for us, and it's making a comment on these. So it's giving you extra information about what each one of these is highlighting. So it can be quite useful just to generate this for your own information, even if you don't intend to then use it or pass the information on. It can be useful if you're not an expert in injection molding, just to read through some of these suggestions and some of this data on the left hand side. So yeah, that's pretty much everything about that you need to know about the molding extension tool within Creo, the molding analysis extension. And yeah, that's the end of this particular tutorial.